Today's topic is half wave uncontrolled rectifier. In this, we will see why we use rectifier first and what do you mean by uncontrolled. Okay, the first thing is rectifier is used for converting AC supply to DC supply. Okay, means means what we basically need is DC supply, because when we can load as a laptop, okay, and what laptop need DC supply to charge their battery. So we need rectifier to convert AC supply which is coming to our home to supply the DC load. Okay, so rectifier is basically used for to supplying AC supply to DC to charge a battery here. Okay, and uncontrolled means we are not controlling, means the output which with DC supply we are getting is not we are controlling. Okay, means we are using simply a diode. Okay, diode as a switch. That's why we cannot control the firing angle of the diode. Okay, and half wave. Half wave means we are getting the output of the DC supply is a half wave. Okay, which we will learn later why we are getting half wave rectifier. And this rectifier we are basically learning for advancement of our study, not for practical purpose, because the efficiency and the power ratio and the other thing is not good for this half wave uncontrolled rectifier. But we have to start our study, so we have to go in a process one by one. So we will use first one switch half wave, then we will go to and learn about half wave semi controlled rectifier, and then we will go for full wave rectifier. Okay, so let's start this topic. Let's make a simple diagram of this. Means what we are doing, we are using a AC supply. Okay, Vs is equals to Vm sin omega t. Okay, and next step is we are using a simple switch as a diode, and one resistive load is connected. Okay, one resistive load is connected, and output voltage is V0 and diode D, and load current is I0 and input current is Is. Okay, and this is the polarity positive and negative for P and N type. First case is this, like this. Okay, here what is happening, we are supplying a simple voltage and a diode is connected and one resistive load is connected, and we will go and analyze one by one what are the factor will affect this load. Okay, what we will get at the load side, what type of waveform we will get, and what are the performance parameters. Okay, the first thing is, first see the output waveform what we got in this. Okay, the input waveform will look like this. Input waveform will look like this. AC supply with a sine, means a sinusoidal supply is like this, 0 to pi to 2 pi. Okay, and the supply of voltage Vs. Okay, and this is the maximum value. Okay, Vm, this is the maximum value Vm. Okay, and the next step is we supply the voltage. Okay, and the condition which we are taking diode as an ideal switch. Okay, we are considering diode as an ideal switch, and we know the condition of ideal switch, the losses, we are not considering the power loss across this diode. But in practical, diode is 0.7 volt into current, that is the power loss. Okay, but here we are considering is a ideal switch. Next step, when we are supplying voltage positive half means Vs is positive right now, means the current will start flowing like this, and come to this point, and this point is a forward bias point for positive half 0 to pi. When this value, the value of anode and cathode, the value of anode is greater than cathode, then diode is in forward bias condition, we know that. Okay, and after that what will happen, this current will flow like this for 0 to pi value. Okay, means the circuit is period, or we can see like this, during on period of diode, during on period of diode, the circuit will look like this. Supply voltage and diode will be replaced by a ideal switch, and resistive load is connected, and R plus minus V output, and this is the switch connected, and this is the ideal switch. Supply voltage I, supply current is I naught, input supply is Is, and Vs, we are supplying this voltage. And for this, what waveform we will get? The waveform for 0 to pi, matlab positive half, the current will flow. Okay, means we will get the current voltage, and ID current is flowing in this diode. At this point, Is current, supply input supply current, okay, is equals to ID is equals to I naught. The same current will flow because these all are in series and circuit is complete, means current is equal. Okay, and what about the output voltage? The output voltage will be, because of resistive load, the output voltage will be same as input voltage for 0 to pi value. Means V output voltage it is same as 0 to pi till pi during diode is on. Here during positive half we are getting V output voltage positive, okay, for on period of diode, means up to 0 to pi period. 0 to pi period we will get the output voltage 0 to pi same as input voltage. Okay, and now we will check for off period. During off period of diode, means from pi to 2 pi. Okay, off period pi to 2 pi means this one is off. So how the circuit diagram will look? Circuit diagram will look like this valve is open, this switch is open. Okay, this means if switch is open, this means Is current, ID current, and I naught current is equals to 0. Means V output is equals to 0 into R. This means this value is also 0. Means we will, what we got at output? We will got nothing at the output side. Means V output is equals to 0. Where? When the supply is on. This means for off period the diode is reversed bias. Okay, the diode is reversed bias. Then these are the conditions, and what we have to check the value of, current Is. Okay, and Is is also equals to I load current, I diode current. The value of the current will be from 0 to pi, and from this to this the current will not flow, means current values of the current for the 2 pi is equals to 0. Okay, and next point is means parameter, performance parameter. The first point come under the performance parameter is the output voltage, average output voltage. The average output voltage V out is equals to, we know that how we calculate integration, area by time t, means this area by time. Okay, because in this output voltage we are not getting pulse for pi to 2 pi, and this circuit is also known as single pulse because we are getting for 0 to pi, only for the single pulse we are getting the output. For area means, area, what do you mean by area? Area means integration. We will calculate the value of this by using integration. Integrate up to where to where? 0 to 2 pi, 0 to 2 pi, and value is this Vs d omega t. Okay, and the time period for this value is 2 pi. The time period for this value is 2 pi. So from here to here we will get 1 by 2 pi 0 to pi Vs is equals to Vm sin omega t, plus for this value 0 pi to 2 pi value is 0, so we will not consider that value. We will get the value of 1 by 2 pi, Vm is common, Vm, and sin omega t if you solve you will get 1 for cos, sin will be converted to the cos and this will be converted to cos. Pi means 1, cos 0 degree is equals to 1, and this will be you get 2 by 2 pi Vm, and 2 and 2 cancel, then V output voltage, V average output voltage is equals to Vm by pi. Vm by pi. This is the important result in this rectifier. And what is the value of I naught? What is the value of I naught? The value of I naught, the value second performance parameter is the value of I naught, and the value of I naught second performance parameter is output voltage. Average output voltage is equals to area by time period. Why we have to calculate when we know the voltage and the resistive load is given R? Then this value is Vm by pi into 1 by R, and this is the value of I naught voltage. This is the second performance parameter. Let's conclude this topic here, and we will discuss this on the next parameter about the input supply voltage and efficiency and utilization power factor. Okay.